Hi everyone, now let's look at this practice exercise 2.2, page 131 of your module. Okay, so this is the questions. Okay, so it is given an infinite surface. Infinite surface is a very big surface, very big plane. So with the current density K, okay, so the K is in the y directions. So at x equals to 1. Okay, so this plane is located at the position x equals to 1. And you are required to find the magnetic field at the position 2, 4, negative 3. So the first thing will be you draw this surface. So I will draw this surface in 2D. Okay, I'll draw this surface in 2D. So since it mentions that the surface is at positions 1, okay, so we will draw it in positions 1. Okay, so draw in position 1. So just imagine this one is your surface. Okay, this is your surface at the positions x equals to 1. Okay, this is x equals to 1. Okay, this is the x-axis. Okay, meaning that this one is at position 1. Okay, right. Okay, so the k is in the y directions. Okay, so the k is in the y directions. Okay, so if you want to draw this current density, okay, you can draw it. Okay, for example, you assume that the y is coming in. Okay, so this is the y directions. So you can draw it. Okay, so the current is in the y directions. Okay, so this is the x directions. So this is the z directions, and this is the y directions. You can just label it as reference. Okay, so you have to find the magnetic field at the position 2, 4, negative 3. Okay, so x equals to 2. Okay, so just now here we label the x equals to 1, right? So 2 is somewhere here. Okay, 2. Okay, 2. Okay, 4 is somewhere that you cannot see. Okay, but the z is negative 3. Okay, so this is the axis z. Okay, like this one. So negative 3 will be somewhere here. Okay, somewhere here. Okay, for example, it's this point, negative 3. Okay, so here will be the position that you want to find the magnetic field. So I just move here. All right. Okay, so you want to find the magnetic field at these positions P. Okay, so we'll be using the equation that we derived earlier. Okay, very simple equations. H is the magnetic field, okay, equals to 1 over 2. Okay, multiply with the K. K is the current density, is a vector, and cross product with the unit vector N. Okay, so we can replace the K. Okay, the K is 3y. Okay, 3y. And this unit vector N you can define by looking at your drawing. So it is a vector that is pointing from your plane, okay, towards the observation point. Okay, so you can look at this blue arrow. Okay, so the blue arrow is in the x directions. It's in the x direction, positive x direction. It's pointing toward the positive x directions. Okay, so you will write here positive x. Okay, so here you will get 3 over 2. Okay, yx. Okay, so you can use this technique to find what is the cross product. Okay, if it is yx. Okay, so y going to the x. Okay, you are in the reverse directions. So you will get negative z. Okay, negative z. Okay, so your magnetic field will be equals to the negative 3 over 2 z ampere per meter. Okay, so very easy. Just like this, you get the answer. Right. Now we look at the question number 2. Okay, the same exercise. We look at the question number 2. Okay, so you have to find the magnetic field again. Okay, find the magnetic field. Okay, at the positions negative 2, 5, and 6 when an infinite plane with the current density negative 4 z, okay, is located at the positions y equals to negative 2. Okay, y equals to -2. Okay, so in this case, we have to draw this thing. Okay, so I draw this axis and I label it as y. Okay, so -2 might be somewhere here, -2. So this one is the plane. Okay, at the positions -2 over here. Okay, -2. The positions -2. Okay, so the current is in the negative z directions. Okay, negative z direction. So maybe here I make a reference. This one will be my y. This one will be my x. Okay, and this one will be my z. Okay, positive z is in these directions. And now it is a negative z. So negative z meaning that, okay, this is my current directions. Negative z. Okay, my current is in the negative z directions. Okay, so find the magnetic field at 2, 5, and 6. So basically, we look at the x and y only. So the x is -2. Okay, -2 is here, the x. Okay, the y is 5. 5 is maybe somewhere here, 5. So you want to know the magnetic field. Okay, above the plane. Okay, the p positions. So one more time, we're using these equations. H equals to 1/2 k and cross with the n. Okay, so in this case, the k is equals to -4. Okay, -4 z. Okay, and the unit vector n is the directions. Okay, pointing from the plane. Okay, pointing from the plane until the observation point. Okay, you can look at this yellow color arrow. Okay, arrow is pointing in the positive y directions. Okay, positive y direction. So here you can write down positive y. So you get the 2. Let's see whether it's a -2 or +2. So you have the x, y, z. Okay, so please use this technique to find. So now is a z cross y. Okay, z cross y. So supposingly you will get -z and -x. And because of this negative, okay, you will eventually get x. Right. Okay, so your answer is 2x ampere per meter. Alright, 2x ampere per meter. Next, we look at the example. Okay, example number 3. Okay, so now example number 3. So example number 3, here you have a 2 infinite surface. Okay, now just now, okay, our question only has one surface. Now you have a 2. Okay, 2 infinite surface, and they are located at different positions. Okay, one is x equals to 3, y equals to 4, and their current density are 7y and 2z respectively. So find the total magnetic field. Okay, since you have a 2 infinite surface plane, okay, so you will have a 2 magnetic field, right? So when they mention about the total magnetic field, okay, so you have to find the magnetic field from the first surface again and plus together with the magnetic field from the second surface. Okay, so let's look at the first surface. Okay, the first surface will be x equals to 3. So we can draw this thing. This is the x. Okay, so the plane is over here. Okay, this point is 3. Position 3. The current density is 7y. Okay, so the observation point is 1, -2, and 5. Okay, so this axis will be z, because the current is in the y directions. Okay, so you can label y directions. Okay, this is your current, okay, in the y directions. Okay, this is x, this is z, and this is y, y directions. Okay, so look at the positions. Observation point is 1, -2, and 5. Okay, 1, okay, 1 is at the bottom, right? Okay, because here is 3, 1 is somewhere here. 5 might be somewhere here. Okay, so now you want to find the magnetic field at position P. Okay, so the hash would be 1 over 2 multiply with the k is 7y, right? And multiply with a cross product with the unit vector n. So look at here, your plane is here, right? So okay, pointing to the observation point, so your unit vector n is in the negative x directions. Okay, so you put negative x here. Okay, so it's a 7 over 2. So for y-x, okay, y-x you get negative z, and because of the negative you get positive z. Okay, so this is the magnetic field, okay, from the first surface. Okay, you can roughly see the answer. Okay, now we look at the second surface. The second surface is at the position y equals to negative 4. Okay, so I draw the other drawing. Okay, so this is y. Negative 4, I label it here. So I will have my plane here. Okay, so the current is flowing in the z positions. Okay, z. So I will label here as my z positions. Okay, z. Okay, so meaning this is y, this is x, and this is z. Okay, so this is the x. Okay, observation point is 1, negative 2, and 5. Okay, 1 is here. Negative 2 is here, right? Negative 2. Right. So 1, negative 2, somewhere here. Okay. Now find the magnetic field is equals to 1 over 2 multiply with the k. K is 2z. Okay, cross product with the directions. So the direction is in the y directions, unit vector n. Okay, y directions. Okay, so you have a zy. Okay, zy you get negative x. So you get negative x ampere per meter. So the hash total, okay, would be negative x, okay, plus 7 over 2 z, okay, ampere per meter. We'll just add them together, right? It's not difficult. Okay, so we go to the next questions. So now an infinite surface plane is located at the position z equals to 1. Okay, you have a surface z equals to 1. So the k is equals to 5 y directions. Okay, now you want to add additional surface plane, okay, at the position z equals to negative 4. What should be is current density, surface current density. Okay, they are asking you what should be the k, okay, to achieve 0 total magnetic field at the positions 2, 2, 3. So the hash total, they want it to be 0. Okay, since you have a 2 plane, right? So your hash total will be the summations of the hash from the first plane, okay, adding together with the hash from the second plane, right? Now they want the hash total to be 0. So it means that the hash 1, okay, should be negative of the hash 2, right? So this is the concept. Okay, so first of all, let's calculate what is the hash 1. Okay, what is the hash 1? Okay, so the hash 1 is a plane located at the z positions, z negative 1. Okay, so z negative 1 is here, negative 1. So you have a plane, this one is your plane, z negative 1. Okay, z negative 1. This is negative 1. Okay, negative 1. Okay, negative 1. Okay, so the observation point is 2, 2, 3. No, the current. Okay, the current density is in the y directions. Okay, y directions. So I will put this one, y directions. So this one is your, this is your z. Okay, this is your y, and this one, the other one will be your x. Okay, observation point is 2, 2, 3. 2 is here, and 2 is y, and your z is 3. 3 is obviously here. Negative 4. Okay, it's here. Okay, so this is your observation point. So your H1, okay, would be 1 over 2, okay, multiply with the 5y. Okay, this is your surface current density, and cross product, okay, with the unit vector n. This is a positive z. Okay, so it is a 5 over 2 yz, you get x. All right, so this is your H1s. Okay, so when you get your H1, it means that you know what is your H2. Okay, so the H2 should be negative 5 over 2 x. Okay, to make it to be 0. Okay, we look at the second plane. The second plane is at the position z equals to negative 4. So I will extend this line. Negative 4 is here. Okay, right, negative 4. Negative 4. Okay, so the current density, you have no idea. Okay, you have no idea the current density. So the observation point is still the same, the point P. Okay, so if you draw the arrow again, yeah, okay, it is in the positive z direction again. Okay, so let's fill out what we have. Okay, so for the H2, it is equals to 1 over 2. Okay, K is something that you have no idea. Okay, and the direction of the n is the z directions. Okay, right. So in order to get it to be a 5 over 2, right? So of course that the magnitude of your surface current density will be 5, right? But whether it's positive or negative, because this one is a direction that you have no ideas, okay? But you know x. In order to get it to be x, okay, the direction of the k would be y, right? It will be y. So you can test it. Yz, are you getting negative x? Yz, you will get positive x, right? So only when this is become negative y, you will get negative x. Okay, so it means that the k, okay, for the second surface will be negative 5 y, ampere per meter. Okay, so you can always try whether it is positive or negative in order to get your answer. It's a negative y, right? It's a negative 5y. Yeah, this one is wrong. Yeah, it's correct. Yz, I get x. So this one is negative x. So yz, I get x. So it should be negative 5y. Yeah. Okay. So this is the answer. Right. This is questions in your module, page 153. Okay. So let's try these questions. Okay, so this one is about the force on a charged particles. So you have to calculate the force, okay, that is experienced by a charge, okay, when it travels at the speed of 2 times 10 power 6, perpendicular to a field of density 2 times 10 negative 7. Okay, so this one is the questions. Okay, so this is topic about the force of a charged particle. So let us use the correct equations, okay, for this one. Okay, to finding the force acting on a charged particle, okay, you will be using these equations. Okay, Q multiply the U, okay, that is the speed, cross product with the B. Okay, B is the magnetic flux density. Okay, so in this question what we have, okay, let's see, we have the Q, right? We have the Q. This is the Q. And we have the speed. Okay, but they didn't give us the directions, right? Okay, perpendicular. Okay, they just mentioned it is perpendicular. Perpendicular means 90 degrees. Okay, meaning that if the U is these directions, okay, your B will be the other directions. So the angles between them is 90 degree. Okay, so you have the B value. Okay, so for these equations, okay, if we write it, okay, by considering the angle between the U and B. Okay, we could write in this way. That is the magnitude of the U multiplied with the magnitude of the B, and also sine theta. Okay, sine theta. Okay, so sine theta and unit vector n. Okay, so this one is how to transform this to this. This one is actually how we have learned it in the multivariable calculus, how to transform the cross product, okay, to this, okay, for the calculations. Right, so for this one, okay, so the answer only requires the value. They don't want the directions. Okay, so we just focus on the directions. That is the U multiplied with the B and also the sine theta. Okay, also sine theta. Okay, so Q is equals to 2 times 10 power negative 18. Okay, and the U is 2 times 10 power 6, and the B is 2 times 10 power negative 7. Okay, so these are the value. So the sine theta, theta is the angle between the U and also the B. Okay, it is perpendicular as mentioned in the question, so it is sine 90. Okay, so you can calculate the answer. Okay, so the answer is equals to 8 times 10 power negative 19 Newton. So this is the force acting on the charge. Okay. Right, we'll go to the next questions. So next question will be question number 2. Okay. Question number 2. Okay, determine the speed. Okay, so maybe here you have to jot down. They want you to find the speed. Okay, speed equals to what? Of a 10 power negative 19 charge. So obviously this one is a Q. Traveling perpendicular to a field flux density, B. Okay, again you see the word perpendicular. If the force is this one. Okay, so this is another questions. Okay, using the same equations, but this round they give you the value of force. They ask you to find the U. Okay, they ask you to find the U. So you'll be using these equations. F equals to Q U B. Okay, so since this one is asking you about the speed, right? And they didn't give you the directions of the B, so you cannot find the directions of the U as well. Okay, so they just want you to find the value. So we eliminate all the vectors, so it will become Q U B sine theta. Okay, so it become this. Okay, so the force is 10 power negative 20. So the Q is 10 power negative 19. And the U is something you don't know. And the B is 10 power negative 7. Alright, sine theta will be sine 90. Right, because perpendicular. Okay, now try to find the U. What is the U? Okay, you can find the U. Okay, find the U. Okay, so from the calculation, the U is 10 power 6. And because it is a velocity, so the unit is this one. Okay, it's very easy. Go to the next questions. Okay, now you have an electron. Okay, electron, okay, it's a charge, right? So this charge has the velocity given, this one, experience no net force. You see the word no net force, meaning that the F is equals to 0. at a point in the magnetic field of this. Okay, and find the electric field at that point. Okay, so let's try to see how we can actually find the electric field. So if we know that the force, okay, for this one will be Q multiply the U cross the B, right? Okay, so the F is given is 0, right? So the Q, okay, you have no idea what's the value, but the U is given and the B is also given. Okay, so how you are going to relate with the E? Okay, so the total force acting on a point, okay, would be the force, okay, from the magnetic field and also the force from the electric field. Am I right? Okay, so when the net force is 0, net force is 0, this is 0. So it means that the Fm is equals to negative Fe. Okay, so what is Fm? Fm is equals to Q U cross B. While this Fe is equals to Q E. Right, so now you start to see the relationship. Okay, so the E will be negative U cross B. Am I right? So the E will be negative U cross the B. Okay, so this is what you can do. So how to perform this? U cross B. Manually you can use this method, right? And you can also solve by using calculator. Okay, your calculator can also solve this one. Right, so the U is 3, 12, negative 4. Three, 5, 3. Oh, this is milli. Maybe we can combine them here. Can we combine? No, I'll just put inside. 5, 12. It's quite crowded. Okay, so the Y is so this is 20, and the Z is alright. Cross product. We learned this in multivariable calculus, right? Okay, so the negative will pull outside first. We go to the X. This is milli, milli. Okay, so 12. So you get 36K minus, this is negative, become plus. Okay, this is 8K. This is your X. Minus, now you hide the column Y. So it's 9K minus negative, negative, positive. So 4K. This is Y. And the Z is no, 6K minus $12K XYZ, right? So equals to negative 44K, right? And positive 13K, and negative, or even positive 6K, K B over M. Okay, so this one is your electric field. Is it correct? Okay, so this is how you find the electric field. You can practice how to use calculator as well. Okay, I think it's until at the options of vector. Okay, option 2. You can do the cross product. Okay, right. So here 3 questions.